Hi, this is Dr. D again, and I'd like to welcome you to this brief introduction for experiment P14, just to show you what we're talking about. In this experiment, we're going to be doing some qualitative analysis of the group 1 metal cations. As you learned in the previous lab, this is qualitative analysis. It's not an issue of how much stuff we have in a given mixture, but what particular metal ions we have. The main characteristic of the group 1 metal cations is that they form insoluble chlorides. The three that we're going to study are silver, lead 2, and mercury 1, right? What you're going to do is, first of all, we are going to be receiving a mixture of these ions, right? Which we will then treat with hydrochloric acid. In the presence of hydrochloric acid, these three ions will form chloride precipitates: silver chloride, lead 2 chloride, and mercury 1 chloride. If we were to take this mixture after treating it with HCl and spin it in a centrifuge, we'll be left with a supernatant. For today, we're going to discard a supernatant, but in other types of analysis, you might consider that there could be other groups of ions in here, groups 2, 3, 4. These are groups of cations that do not form insoluble chlorides, okay? So essentially, this is the way the experiment starts. You first make a precipitate of these guys, and our strategy, don't forget, as we mentioned earlier, was you first is the process of separation. In other words, you design a series of reactions that will separate your ions. And then our second step will be a step where we do the confirmation. In other words, believing that we have a certain ion in a particular fraction of our process, we will confirm that that ion is there, okay? So that's how this is gonna work. Okay, so a couple of things to keep in mind is as we go through the process is that once you have the precipitates of lead 2 chloride, silver chloride, and mercury chloride, mercury 1 chloride. The important thing is that among these three, lead chloride is more soluble in hot water. So if I have already centrifuged and I have this precipitate in water, and I add hot water, the idea is that now the lead chloride will dissolve, releasing therefore lead 2 ions, whereas the silver chloride and the mercury 1 chloride will remain insoluble. So if you can add hot water and centrifuge this mixture, in effect, what you're going to end up doing is you're going to be redissolving the lead 2 ions, while you will be leaving here with a precipitate of these. Now, at this point, we don't want to spin. What we'd like to do is separate them. So what we will do is we'll add the hot water, and then what we will do is we will filter this mixture. And see, this is where sometimes the strategy changes. You would think that once you have precipitates, all you do is centrifuge and get a pellet and get a supernatant. But in this case, what we're going to do is we're going to filter it, because in the next step, we're going to use a single reaction to separate the silver and the mercury 1 ions. So if we do a filtration, and your lab manual shows you here on page 50 how you'll do that. right? You're going to set up a filter with a filter paper. Make sure that when you filter, the water is still hot. And what will happen is that now you will have, instead of a pellet and a supernatant, what you will have is a filtrate and a residue. Okay, so the filtrate is the liquid that goes through the filter paper. This filtrate should be the one that has the lead-2 ions in it. The residue should still have silver chloride and mercury-1 chloride. Both of these are still stuck in the filter in a solid form, all right? Now, at this point, we are able to confirm for the presence of lead ions. And we'll do that simply by allowing the mixture to cool, right? But if it doesn't work, then what we can do is simply we can add some extra acid. So we can let this cool down. If need to, we can add some more HCl. And what should happen now is that you should recover again the precipitate of lead chloride. Oops, sorry. Let me see. Getting this. It's okay. And this will be your confirmation. In other words, if after taking your chloride precipitate, redissolving it in hot water, filtering, if your filtrate reprecipitates after cooling the water down and adding more acid, then that means that you had lead in there. Now let's see what we're going to do with the stuff that was left on the filter paper. So remember, at this point, you have a residue that has your silver chloride and your mercury-1 chloride. What we're going to do with this is we're going to do a wash with ammonia. Notice that in this explanation, I'm not giving you details about the molarities or concentrations because that's all in your lab manual. And I'm just going to give you an idea of the strategies here. Now, here's what happens here. So silver chloride, of course, is actually a substance that, although insoluble, as we'll learn later on in the semester, all of these so-called insoluble precipitates are actually in equilibrium between the insoluble form and the dissolved and dissociated ions. This, of course, has a very small equilibrium constant, all right? However, silver ions, so this has a very, very small equilibrium constant, which, by the way, we're going to learn later on, it's called Ks, or the solubility product. Now, it turns out that silver ions are also capable, in solution, of reacting with ammonia in a 2-to-1 ratio and forming a complex that is highly soluble. It's called a complex ion, and it's very soluble. So in essence, think of the Le Chatelier principle. If I'm coming in here and I'm adding ammonia, that ammonia is coming in here and essentially pushing this equilibrium towards the right, right? Because it's a very, it has a very high equilibrium constant. So think Le Chatelier. If this side of the equation becomes quote unquote heavier because there's more ammonia, the equilibrium shifts towards the right. But as it does, what it's doing is it's removing silver ions from the little bit of silver ions that are in solution are getting removed. And so as a result, right, as a result of adding ammonia, pushing this equilibrium to the right, you're essentially removing ions from the solution, which means that now, again, by Le Chatelier principle, if I'm removing products from this equilibrium, that means that this equilibrium has to shift towards the right. In other words, you are essentially causing the silver chloride precipitate to dissolve in the presence of the ammonia, right? Now, what about the mercury chloride? Well, the mercury 1 chloride has an interesting reaction with ammonia. It's very different than the one we just saw here. Let me write it down for you. So basically, your mercury 1 chloride also reacts with ammonia. But this reaction is actually an oxidation reduction reaction or redox reaction. What it causes is it causes some of the mercury ions to become reduced to neutral mercury, which actually will be somewhat liquefied but has a dark color. You're also going to end up producing a compound that is essentially a kind of like a what we call sometimes a coordination or complex. This is essentially a white solid, and the other product is going to be simply ammonium chloride, which will stay in solution. So between the black mercury and the white complex of mercury here, what's going to happen is you're going to get something like a dark gray solid, right? So again, coming back to what we did up here on the top, if I now take this residue, and remember, this residue is currently on the filter paper. And I wash it with ammonia. What's going to happen is the silver is going to redissolve, right, in the form of this complex. And that's going to flow through into the filtrate, whereas the mercury will form this mix where, you know, some of the mercury becomes reduced, and this will stay on the filter. It'll have a dark gray color. And that essentially is the conformation for mercury. In terms of the silver, once we have it in the filtrate, we're going to do a conformation for silver. And again, once more, let us consider that we had this complex here that was formed, right? We have the silver ions that are, you know, forming this complex with ammonia. The complex ion. Now, what happens if I add acid to this? Okay. Well, what's going to happen now is that the ammonia will react with your acid. And just like a good old acid-base reaction, we end up getting ammonium ions. But once more, remember, the important thing here was that the ammonia was there to help keep the silver ions in solution and not reprecipitating with chlorides. Now what I'm doing is I am essentially removing ammonia from this equilibrium. And if I'm removing ammonia from this equilibrium, that means that this equilibrium on the top here is going to shift towards the left, just by Le Chatelier principle. And that means that if I have that equilibrium shifting to the left, in other words, if I'm generating more of these silver ions, right? Remember that the silver was originally sequestered away from the chloride ions by the formation of this complex. But if now I'm losing that complex because the ammonia is getting removed, that means that now this equilibrium is producing more of these ions. And therefore, what's going to happen is that you're going to get another equilibrium shift here by Le Chatelier. As the silver ions increase, this moves back here, and so you get a reprecipitation. So the way we confirm silver is we take the filtrate from the ammonia wash, we add acid. In this case, what we're going to do is we're going to add nitric acid, perhaps, because if we were to add HCl, okay, so we don't want to add HCl here. We don't want HCl because if we did, then we are going to add chloride ions. And at this point, the idea is that there shouldn't be anything in this filter except silver. So we're gonna add if we add HCl, this would bring in chloride ions, and that could make a contaminant. For example, any mercury, or I'm sorry, or lead contaminant precipitate, right? That's why we don't want to use HCl at this point, because if anything filtered through, if anything leaked through from the other stages in the preparation, and it's sitting here, adding chloride ions is going to reprecipitate anyway. We're trying to make sure that what precipitates here is exclusively silver. So we're going to add the nitric acid, and then that means that if we form a new precipitate of silver chloride, these chloride ions were already there from before, right? This is our confirmation that silver was present, okay? So what I want to do now is I'm going to switch over here to show you the flow chart. So it's very important when you do these kinds of analysis that you have a flow chart. I know that some students don't like flow charts. Some people just don't like anything that has to look like a map. Like, for example, my wife doesn't like to read maps, and some people don't like flow charts. However, this is a very useful way of summarizing everything we're doing. The only thing that's missing here is remember that after we precipitate the initial mixture with HCl and we have our precipitate and we dissolve in water, remember that at this point, excuse me, at this point, we have to filter it. We're going to get a filtrate that should have the lead 2 ions and a residue that has the silver and the mercury 1 chlorides, right? Notice that here we're going to cool the lead mixture, add some more HCl, and if we see a precipitate, that confirms that we had lead 2 chloride. Here we're going to wash the filter with ammonia. And again, in the filtrate, we should be getting the complex ion of silver now, which keeps it in solution. But then when we add acid to that mixture and we remove the ammonia, the silver and the chloride ions rejoin and form this precipitate. At the same time, when we add the ammonia, it was a kind of a double whammy here, because the ammonia would have reduced the silver, the mercury ions into mercury, excuse me, and that'll give us a solid precipitate, right? So this is a very useful type of approach. Now, let me take you back here for a moment. Hold on a second. I'm gonna come here. I'm gonna come back to my face here. Sorry to bug you with my face, I'm sorry. But let me show you what, excuse me. Excuse me. Let me show you what your lab is going to look like. Okay, I'm going to come back here and I'm going to go to this screen here. Here we go. Okay, so when you go to your assignment in Canvas, you're going to have some instructions. You'll be able to watch this video that we're doing right now. And what's going to happen is you're going to see a document that has the kind of like the pictures corresponding to a group 1 mixture. You can see over here, right? You can see over here the same flow chart that I just showed you earlier on, right? With all these steps in here. Let me show you what they look like. Okay, it's in here. Let me pull this out of the way. And you're going to start with a mixture, which is going to look just simply like liquid, like it looks like in here, right? And then after you've added your acid, you're going to see a precipitate form, which you will then spin to get it separated from the liquid. You'll decant the supernatant, give it an extra wash, and then have a clean pellet in there. Notice that in this flow chart, there are numbers that correspond to the steps that are outlined in your lab manual. In the same way, these pictures here have the same numbers, so you can see what is happening at each one of those steps. So notice that when you add the hot water, okay, here we are, you're gonna have a precipitate, a residue on the filter paper. That residue should have essentially your mercury, right? And your lead ions. So let me see if I can write that in here. Okay, here. So basically this should be here silver chloride, and it should also be your mercury chloride precipitates. Whereas over here, what you would have is a filtrate that has supposedly your lead ions. Remember, what we're going to do now is we're going to try to see if we can confirm that. So here is the next step, is after you've chilled the tube, you can see that again, a precipitate has formed, right? And that is your confirmation that lead ion had been present in the initial mixture. Now, with this residue here, this is the one that, again, you go back to your flow chart here. This is your residue. You're going to now wash that filter paper with ammonia, all right? And the ammonia is going to do a couple of things. One of them is, as you can see here, it is going to cause your mercury ions to reduce and form this dark solid there, and you can visualize it. The filtrate, on the other hand, as you can see, has a, I'm sorry, Your filtrate here, as you can see, has it should be clear at this point. But what will happen is once, oops, where is that? Once you have added nitric acid, it says here, or HCl, I would go with nitric acid because again, like I said, the HCl just adds more chloride ions. And if any of these other guys that were here somehow leak through, for example, let's say that the lead, some of the lead didn't actually dissolve in the hot water and stayed here, and now it filtered through simply because it did, and now you're going to have lead ions. And if you add HCl, of course, it's going to precipitate. You want to add nitric acid because all that brings here as an important reactant is the actual hydrogen ions that they essentially, as we explained earlier, they are going to remove the ammonia and they're going to cause the silver ion to reprecipitate as a chloride. Okay, so essentially that is the way that this looks. Now, on top of this document, I'm sorry, not on top of it, besides this document, what's going to happen is, let me stop sharing here, right? You're going to be receiving also a file that has a similar set of pictures to the one you just saw, right? And what will happen is, in that set of pictures, some of those reactions will look the same, some of them won't. So what you'll have to do is you'll have to decide whether a given ion is present or not in that particular unknown. Now, what I usually recommend is the following. Let me come back here to our picture that we did before. Okay, here we go again. So this is the flow chart that was given to you. Normally, what you want to do in preparation for one of these labs is to do your own flow chart. I'm sorry. Piece of paper. Yeah, I don't have a piece of paper, so I'll use this one that's over here. Okay, so, no. Oh, sorry, it's right underneath. Sorry. Oh, oops. I guess not. Camera here. All right, there we go. So again, please let me I'm gonna make a little change here. All right, there we go. Here, and let's go back to this paper here. So what I would recommend you do is do your own flow chart. This is a flow chart that you make, like a sample flow chart that you can make. So, for example, here's your unknown, right? Remember, your unknown could have any one of the three group 3 ions. So obviously, your first step would be to add HCl and ask yourself, does it form a precipitate? Because if it doesn't, then that would mean that there are no group 1 ions in here. And you might say, well, that's kind of like beside the point, since I know there are. Well, you don't. You have to assume from the start that you might not have one. Also, what if it didn't work? What if you added the wrong thing here? What if you, instead of adding HCl, you added nitric acid here instead of HCl, and you didn't get a precipitate? So you got to be careful with that. Now, if you did get a precipitate, then of course you are going to spin it, right? And then you are going to add hot water. And there you're going to ask, does the precipitate dissolve? If the answer is yes, then that means that you possibly have your lead ions in there. And so you will have to confirm by chilling and asking, do I get a precipitate here? If the answer is yes, then that means that this confirms the presence of lead ions. In other words, if all your precipitate dissolves, if all your precipitate dissolves, then what that means is that the only thing you had in there was lead chloride, but you want to confirm it by chilling the mixture and see if it reprecipitates, right? Now, let's say that the answer is that no, it didn't all precipitate. So that means that you have silver or mercury might be there, right? Silver or mercury one might be there. These are possible. Now, remember, at this point, you don't know if the precipitate dissolved or not. So what you want to do is you want to filter. And remember, you want to do this, filter it hot. And you want to test your filtrate to see if the filtrate has some lead in it. Because you don't know. At this point, you cannot tell if any of your precipitate, if all of it dissolved, then you're pretty sure it was lead that was in there. But if it didn't, there might still be some lead ions in there, but there might be something else. Now, at this point, you have your residue. And then you want to check, do I have silver or do I have mercury? So what I'm going to do is I'm going to do a ammonia wash. All right. Yeah. Hold on a second here. Let me see if I can scroll this over here. Oh, there we go. Sorry. Your ammonia wash, and you ask, do I have a dark residue on the filter paper? If the answer is yes, then that means that mercury ions were present. If I don't get a dark residue, that means there was no mercury ions present. Then what I want to do is I want to take the filtrate from here, and I want to add nitric acid and ask, do I get a precipitate here? PPT means precipitate. If the answer is yes, then that means that silver ions were present in my original mixture. If the answer is no, then that suggests silver was not present. However, one of the things the lab manual reminds you is that when you get this spot, you want to check with litmus paper to make sure that you are making the solution acidic enough. In other words, you've neutralized all the ammonia so that if you don't get a precipitate, don't let it be because you didn't neutralize all the ammonia. Okay, so make sure that this is acid. So, yeah, I gotta admit this way I wrote it here, it looks a little messy. I'm sure that some of you are better artists than me and you can do a better job. But the idea is that anytime you are faced with this kind of an experiment, you want to come ready with a flow chart where after having gone through analyzing a mixture of known ions, right? You are able to now set up a strategy so that if you're given an unknown and you are told, you know, this may have silver or it may have lead 2 ions or it may have mercury 1 ions or it could have 2 of them or it could have all 3 of them. So a flowchart allows you to set up. Notice that this flowchart that I just showed you is a little different from the one the book gives you, because the lab manual gives you a flowchart for a mixture where you know what's in there. This is a flowchart for when you don't know what is in there. Okay, so this is your experiment. So once more, when you go to your Canvas assignment, what's going to pull up is a set of instructions. You're going to have this video with my introduction. You're going to have a document that shows those pictures that I showed you earlier on about what the reactions look like. And each student is going to receive individually like a PDF, like a file that has also a sequence of pictures. And based on what you observe in those pictures, you're going to have to be deciding which ions are present and which ones are absent in your unknown. And so what will happen is, let me come back here one last time to our camera. Of course, when you did the first set of observations, this was with the known set. What they want you to do is to write down here, what are the observations? In this case, of course, you're not doing the reactions, you're just looking at the pictures on that document that I just showed you a little while ago. And then what you will do is on this other page, this is on page 53, data sheet number 2, what you'll have is, you're gonna have here, what is your unknown number? I don't know, number, say 5 or H or whatever, depending on what the nomenclature is gonna be. And then over here, you can have two things. Either you can just write down in words your observations. My preference is that you use this space here, okay, to draw your flow chart of searching for the unknown, where you highlight the steps where you actually were able to confirm the presence of an ion, and then write down which of the three are present in here. Again, it may be one, it may be two of them, it may be all three of them, okay? So that's what's gonna happen. Once you have collected these, you will be submitting in your lab report, you'll be submitting data sheet number 1 and data sheet number 2. If you did your flowchart on a separate piece of paper, then just attach that as a separate piece of paper, all right? So that's essentially what this experiment is all about. And it's unfortunate that because of the current situation, you are not able to do this hands-on. But because you did the first lab where you practice with separating, group 1, group 2, group 3, uh, that should give you enough of an idea of how this works. And hopefully in the future, if you had to do a similar experiment, you pretty much understand what the techniques are, okay? If you have any questions, send me an email or send me a text message. You have my text phone number on your syllabus, or you can just put a message in your inbox in Canvas, okay? Thank you so much. It's been great being with you, and I'll see you soon.